All right. Good morning, everyone. Welcome. Thanks for joining us today for our hybrid event. We are here at Clackamas Community College, and we are going to be doing time travel 2017 to 2024 to kind of take a look at the progression of CAD/CAM software in the last 7 years. So today, let's go ahead and move forward on the slides. Come on in and grab a seat. Excellent. Thank you very much. All right, so today we're going to be going over 7 years worth of CAD/CAM development. Obviously not every single update, but we're going to go over some of the interesting ones and ones that might compel you to say, oh, well, that's pretty interesting. Might want to look a little bit deeper. I want to do a couple of quick introductions. My name is John Stauffer. I'm an apps engineer at MCAM Northwest, the Mastercam reseller for the area. I've been there for about 4.5 years, and I've been machining since January of 2011. That's when I started. And yeah, it's been quite a wild ride working here. And what's really fun is that before I did this, I was actually at school for Mastercam with Charlie Lettenmeyer as my teacher, who happens to be here today. And I would really like Charlie to come up and just give a few words on Clackamas Community College and kind of what they do in the area. Come right up here, and we'll just near.
Okay. Hi, everyone. I'm Charlie Lettenmeyer. I've been instructor here at the college for 8 years now. I've been using Mastercam since 1989, so it goes back quite a ways. If anybody remembers the old DOS version. We have a really great program here. We teach everything from just like how to basically start with drawing a line, drawing an arc, how to trim, all the way to advanced 5-axis programming. And we actually have the capabilities of running those programs on our shop floor now. One of the beauties about our program right now is the primary classes, the ones that John took, are actually all online now. So it doesn't matter where you are in the country, or even if you're in the area and you just want to go to school from home, you can sign in, watch the lectures, and then go through and do the projects. I mean, it's actually really very cool. Very, very worthwhile program, I feel. So
excellent. Yeah. Thanks so much, Charlie. I appreciate that. All right. As I readjust slightly here, put that back. Excellent. All right. So couple quick notes on housekeeping just while we're going here. I really hope that everyone who's here live will stay for the whole presentation. But if you can't, or if you're online and you can't stay, there will be a recording of this presentation available on mcamnw.com/videos. Normally, I would have it up by next week, but I'm actually on vacation next week, so it'll probably be the week after that. If you are online, if you have any questions, please enter those into the Demio chat panel at any time. Kyler is behind the computer here, and he will let me know if there's questions, and we'll address those. If you guys live have any questions at any time, just raise your hand, and we'll go ahead and dive into it, okay? Excellent. All right, so let's go into the first slide. I kind of wanted to start with, before we look at all the differences, what are some of the things that are the same between older versions and newer versions? And first one would be that Mastercam is still the #1 CAM software for professional use in the world, period. We've seen a lot more fusion come up, but when you're looking at the professional application, real machine shops that are doing production work to make money, it's definitely still Mastercam. The interface between 2017 and 2024 hasn't had too big of a change. Overall, the system's pretty much the same. So if you are running a version like 2017, it's not like making the switch from an X version to one of these 4-digit number versions. That was a really big change when we moved from hieroglyphics to text and images. I personally really prefer the newer one. The other thing that you can still do is customize, right? Mastercam is very customizable. And so if you want to change the way that your toolbars look, if you want to change your right-click options and all that, that all still works the same way. You're not locked into doing it a certain way. You can always do things in your own way. Post compatibility, for the most part, posts are still pretty compatible if you're coming from an older version to a newer version. There are some caveats to that. There's a couple of specific toolpaths that are newer that may not be compatible with the post, but most of it is. So what you'll want to do if you're moving from an old version to a new one is try out some of that stuff and just have a mind of, okay, we might need to have a post adjustment made, which isn't a big deal. We can get those things done. Consistency in the workflow concept. So this is a little wordy, but I'm going to try and break it down in a way that makes sense. With Mastercam, whenever you're learning something new, like you've got some knowledge in one sector and now you're trying to learn something new, what you might notice after a while is that even though the controls are different and you're doing something different, the way that you get about it is more or less the same, right? You might have some things to say, oh, well, you know, I'm calling it this and I'm calling it this, but you know, by reading it and some application from the past, generally how to deal with that. After a while, it kind of clicks, right? Once you're past that kind of, I do this because it works. I do this because it does X, Y, Z, right? So once you've learned that, you can really continue to apply it everywhere. And that applies to new versions. So if you've learned how to do programming in 2017, moving to 2024, while you might have some new options there and things will look different, if you take the time to read through the dialogue, you can still pick back up on it. Legacy support. So if you really want to use the wireframe toolpaths for some reason, or you have a real need to use something that's from a very old version that isn't even in the main interface anymore, you still have the option to do so. You can right click in your toolpaths manager and you can access that function. There's hardly anything that is truly gone. The only instance I can really think of is in more modern versions of Mastercam, the new unified toolpath has taken over a lot of the multi-axis. And so if you're looking for, say, the parallel toolpath in multi-axis, you can't find it anymore. But it's not because it doesn't exist, it's because it lives somewhere else. But we do still support basically everything. You can bring a program from, you know, X5 into 2024, and it'll still regen and work. It might even be better. Oh, and don't forget, Command Finder. It's a fantastic little tool. On the Home tab, far right-hand side is Command Finder. You can click that, you can type in whatever you want, and it will find that command for you. So even if you don't know the interface, that's a quick way to at least get going while you're learning. Let's go ahead and go to the next slide here. So a couple of general differences. First, we have more support for additional file types. Some of this is from the CAD world for modeling. Some of it is a little more lean towards the 3D printing side of things. Mastercam's been kind of getting into additive for a few years now. And as we do that, we're adding more and more file formats that are friendly to that. We also now have mesh creation and editing tools. So that can be really helpful if you're building STLs, or if, let's say, you need to work from a piece of stock that's been scanned with a laser scanner. We can now import that. You can modify it if need be, and you can use that as your stock or your part or whatever you need. You now have the access to free training videos at Mastercam University. So this is a site. You go to mastercam.com, you get logged in with your login. Even if you're not a user, right? If you're a student or if you're just interested in getting into Mastercam, you can make a login. You can go to Mastercam University and you can learn how to use Mastercam 100% for free. And you can get a free copy of the Mastercam Learning Edition alongside that to learn. So the Mastercam University itself isn't actually new, but the fact that it's now free to everyone is new. That started 3 weeks ago, I think. I mean, it just came out. So pretty neat. We do like that, especially for some of the basics. There's also new options for additive manufacturing built in. If you guys haven't heard about this, there is an add-on for Mastercam called A+, which allows you to take a metal depositing head and attach it to your machine and then actually do essentially 3D printing with metal on your machine. Then you can go back and machine down. There's some really interesting implications with being able to both add and subtract material on the same machine without moving your part. There's some really cool stuff you can do with that, and we now have support for it. We do have better modeling tools. Every year, Mastercam goes through and adds in new modeling stuff. So that's been really awesome to see. Learning Edition improvements. With the Learning Edition, you can access absolutely everything. You can even do full-on mill turn programming with the Learning Edition. You just can't post the code, but you can learn about it, right? General processing improvements. So in general, it just does a better job at actually calculating things. So my example for this, I was getting ready for this and I had to go back and kind of learn 2017 because I never really used it. You know, I started in 2019, right, Charlie? That's when I started. And so I had to go back to 2017 to learn how to do some stuff. And I was building this OptiRough toolpath. And once it was all built and I was going to regenerate it, it took 31 seconds for me to regenerate that toolpath on that computer. Then I took the same program, moved it up to 2024 and regenerated, and it took 2 seconds to regenerate it. The processing is significantly better right now. So that alone could save you quite a bit of money just moving up. And there's so many more things. We don't have time. There's 952 pages worth of what's new documentation between 2017 and 2024. Yeah, nearly 1,000 pages. That's like all of Lord of the Rings. So it's a lot. You know, so there's tons to go over. But again, we don't need to worry about knowing every single one of those things because that's not going to apply to you, right? I don't know anyone who actually uses Mastercam for everything from the very beginning to the very end and uses every single one of the products. No one does that. If you did, you'd be a contract programmer making a lot of money. So maybe there's some. So let's go ahead and go to the next slide here. And I'm going to start with just some mill updates, just some basics here. So there's several selection methods that are new to 2024 compared to 2017 and kind of everywhere sprinkled in between. This isn't a direct comparison necessarily. We have some expanded air regions, which is how you get this behavior. This is really cool. We'll talk about that. We have helixing is much smarter now than it used to be. You now have OptiRough included with the mill license, which is huge. General processing speed, again, I kind of mentioned that already. Multiple machine geometry groups allow you to leave stock differently in different areas of your part, which can be really useful in some cases. The new model chamfer toolpath, fantastic, way better way to do this, and I'll show you why in this kind of situation. And also change at point with solid chaining. Change at point isn't new, but the ability to use that with solid chaining is newer. It's 2020, probably 2020 or so. So let's go ahead and switch to my computer. And I want to start by taking a look at this in 2024. Simple part, really simple. You guys have probably seen this before. Used it for a bunch of different things. What I want to do is just start by doing a simple dynamic mill, and I'm going to start with this pocket in the middle. So let's go to a top view, and then I'll open up my dynamic mill op. You can check there. And then essentially my machining region is really just going to be that face. So I'll go to solid selection, face, solids. My highlight doesn't work quite so well in this version. That's an issue with 2017 trying to run on parallels for Mac. It's kind of a weird one. So there's that. And if I preview my chain, that's what it looks like. So that's pretty simple, pretty easy. I'm going to use this 3/8 flat end mill. We're going to use a lot of defaults here because it's not what I'm super worried about. But what I do want to take a look at is what the motion looks like once we run this. All these values should be okay. Always turn on your arc filtering for dynamic operations. I'm just going to do a 50-50 split with a 5 thousandths tolerance. Close enough. Okay, so basic dynamic mill operation looks pretty good until you notice this little funny loop here. That's kind of weird. If you put this into backplot and turn on the option for the simple verify, this adds a, let's see here. Oh, wow, is that not showing anywhere? I might actually be having an issue with this. Yeah, I don't think that's actually working correctly. Oh, darn. Okay, so essentially, what's happening here? I don't know if the camera can catch me. Can you still catch me here? Yeah. Okay, great. So what's happening is the tool is helixing in. The problem is that the diameter of the tool is 375, but the helix that Mastercam gives us by default is 1/4 inch. That means that by the time it's done spinning around, there's actually a post in the middle of that helix. And that kills tools really quickly. So in 2024, we don't have to worry about that. If I do the same thing, go to dynamic, I'll use an automatic region this time. It's a little easier. Green check, green check. Same basic thing. This is actually the same program. You might notice this little yellow bar. So I made all the program in 2017, and then I brought it to 2024. So I have the same tool libraries, same everything. And we'll set up a basic arc filter. Same thing, all the other stuff at defaults, again, not touching anything differently. We're going to get a different result here. And so if we run that helix, no post in the middle. Because what this toolpath will do is it will actually look at the tool that you're using and adjust that helix depending on your tool without you even doing anything. That helix radius set for 16875 is 45% of the diameter of the tool, right? So that's what removes that post. And it does that automatically for any tool you select. Pretty nice. Don't have to think about it. I like not having to think about it. Got to go fast, right? We got to get things done. So that's number one. Number two, let's take a look at chaining and how chaining works in general. So next thing I want to do is, if we look at the front of the part, there's this pocket here. I want to mill that out. I'm going to come from outside. I'm going to use dynamic again because it's easy and I can. So for my machining region here, I'm going to use the linked edges option. And actually, you know what? My machining region is just a face. My bad, there we go. And then I can use stay inside as long as I set an air region. That will allow the tool to come in from outside anyways, and then I don't have to set an avoidance, which is a fun little tip in case you didn't know that. So I'll set an air region. Now the only way to set an air region here is to set this to linked edges and then come in here and make that selection just like that. Then if I preview my chain, that's what I get. So this is telling Mastercam that blue area is wherever the tool can just drop in without consequence and then do the milling as needed. Again, I'm going to use basically defaults here. I'm not too worried about stuff. This should all be preset. And there is our toolpath. Looks pretty good. Pretty much what I expect out of it. But I think we could do it a little bit better with 2024. The reason why, if we look at this from a top view and kind of run the first pass in here, let's see if we can get that tool visible. So the way that this is going to swing into the cut, you can actually see right here what it's doing. And it's swinging in, but it's not actually getting this direction very well. It's kind of coming straight in. And that's not ideal. And it's going to do the same thing on the other end. It's going to go straight out. Let's take a look at this in 24 in the correct window. There we go. And this time I'll use dynamic, but I'm going to use my automatic regions. Automatic regions, I just select a face and preview chain. And I've already got the same thing, but kind of a little different. So the automatic regions, it automatically finds walls that are higher, and it's going to set that up as part of the avoidance, and then it's going to set up any area that's outside and not touching as an air region. I can also expand that air region. Whoops, preview those chains again. And notice the way that it kind of bulbs out a little bit more. This actually changes the way the tool engages in that first pass. This will bring the tool in more tangent to the cut, which is better for your tools. I think all the defaults here are still going to be good. Neat. Now, what I really like about that is it means I can do this. In 2017, if I wanted to now add in dynamic for this face and this face and this one and this one, I would have to do all that chaining all over again for each one of those. And it's laborious and it takes a lot of time. And I don't even want to do it because we don't have time to waste. So 2024, name tags, they just fall right off. My name's John. Actually, I'm not even going to start a new operation. I'm going to take this existing one. I'm going to copy paste it, go to my geometry, select a new region here. Green check, regenerate. paste, geometry, kill it, get a new one, click this, okay, okay, regenerate. Boom, 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 right? Get it done fast, because it can do that processing for you and you don't have to spend your time trying to keep up. Kyler, can we go back to the slide deck for a second? I want to make sure I'm not missing something. I think I'm missing something. Yes, okay. So OptiRough is another one. Is anyone here not familiar with OptiRough? Not familiar? Not familiar, okay. So OptiRough is a 3D roughing toolpath. It's really similar to 2D Dynamic in the way that it approaches the cut. It's just, it can actually do this on a 3D scale. So if you have like a tapered wall, it will go down, it'll go as deep axially as it can, then go out radially as far as it can. Then it starts stepping up and making smaller cuts on this way up. But you don't have to have a tapered wall to take advantage of it. A part like this is actually great for OptiRough. It'll do this too. But one thing about OptiRough that's pretty interesting, if I were to come in here and set this up, this is what it looks like in 2024. I set my machining geometry. And in this case, the easiest way to do this is to just pick the whole part. So let's see, I'll leave some wall stock, like 20 thousandths, and then we'll take the floors to 0 because this tool could probably handle it, right? So my whole part is picked. Now, you could do the same thing in 2017, but what you can't do in 2017 is what if one of these faces needs a ground finish? I can't actually machine it. What you can do is you can add a group like this and say leave for grind, and then I can make a selection there. So let's say that that face there needs to be ground. So I add it there, and then here the wall stock and the floor stock are going to be different. So I'm still 20 on the walls, but my floor is going to be 50. And so this will leave a different floor stock than the rest of the toolpath. You can't do that in 2017 because you only get one field to leave stock on the walls and the floors for everything, no matter what you select. So that does limit you. Is there a way around that? Yeah, if you like duplicate your OptiRough, you start with what you want for the grind, and then you do your second one when you add an avoidance region. But it's so much more work, right? Like that's what we're getting away from. The last thing I wanted to show you on this part was the chamfers. So let's take a look at these chamfers in here. I've got some really little chamfers down in these corners on the edges. I'm just breaking an edge. That's all it is, right? If you were going to do this in 2017, you would use the contour toolpath, right? You would set it for 2D chamfer, and then you'd have to go to the lead in, lead out page, turn on the extend or shorten, and you'd have to sit there and play with that until it's as close to this edge as you could possibly get, right? That's how you would do it. But in 2024 and several versions earlier, you don't have to go through that process. You can simply select the model chamfer toolpath. This one is model aware. So once we select our edges, it's going to know which model we're dealing with, and it can automatically make the tool avoid any other walls by a given value here. So let's say I wanted to make those cuts up to within 2 thousandths. I don't want to get any closer than 2 thousandths. Then I can set up my chain geometry. The nice thing about this is that because all the chamfers are modeled in, and I don't have to do anything fancy, I can just select basically every edge that's outside and unconnected, which is actually this selection method right here. So I can just click these faces, and it selects all those edges for me really quickly. Pick my tool. Cut parameters, our chamfer width would be 0 because it's modeled in. We'll just do a bottom offset. Or no, let's do a top offset. Let's make this really effective. This takes a better advantage of the diameter of the tool. And you know what, the rest of this should probably be fine. And there we go. So that's chamfering all of those edges quickly and easily with one simple toolpath. And I'm not sitting there having to dial everything. The problem with dialing too is that you might have to dial differently depending on where your intersections are and how they come together. I might have to back off more or go a little farther. Here, I don't think about it. I just tell it, get within 2 thou of a wall, go for it. And it does it. This is really good. If you're doing this kind of work, get used to using the model chamfer because this will save you deburr time on the bench. That's always good. Let's go ahead and go back to the slide deck. You have any questions so far?
Yeah, on that model chamfer, does the model need to show the chamfer? I don't have to look at it from the edge.
So the question was, does the model need to show the chamfer in order to use the model chamfer toolpath? The answer to that is no. So in the toolpath, actually, we could jump back there for a second. Sorry, Kyler, I'm just throwing them all over. So in the toolpath, in the parameters, this chamfer width field here, that's what controls the chamfer size. So if your chamfer is already on your part, leave it at 0, and then it will just cut it to size as modeled. If you don't have it modeled in, then you put in the chamfer width you want here. If you have a mix, separate separate it into 2 toolpaths so that the ones that have the chamfer don't get over chamfered. Yes.
Now, let's just select the top surface of the part. Is that gonna select, like, so if the chamfer's already in the model, is it gonna select a smaller geometry because it's technically like, if it's a 10,000 chamfer, about 10,000 in off the wall? Or is it gonna kind of compensate to the corner or to the theoretical corner?
So the question was, how is it going to compensate essentially based on the selection that we used?
Correct.
Yeah. So let's take a look at it. If we, I did not mean to click verify. Okay. So, and we'll turn off the quick verify for this. Miss my 3D controller. Although this GView cube's really neat, like that. Okay, so you can kind of see the way that this sits now, right? So it's gonna sit right along that chamfer because it knows the definition of the tool and the definition of that chamfer. And when you're doing it this way, you pick that top edge and it will compensate that way. When you get into a corner, right, where your tool's coming up on a sidewall and you're gonna crash, it's going to cut that a little short. It's not gonna get all the way in there. That's a limitation of the tool size and the corner. Like, you physically can't get the tool in there. You could try to drop it a little farther and come farther out, but that doesn't, that's not supported with the model chamfer toolpath.
Where is that setting for avoidance?
So the setting for avoidance, if we go into the parameters, the question was, where's the setting for the avoidance? If you go on the toolpath type page, the field here labeled solid model side clearance. So that's where you set the side clearance from your tool to your part. It knows what the solid model is as soon as you pick your geometry that is based off of a solid model. It'll use that automatically. Now, if you also have other things that you might want to avoid, if you have fixturing popping up or something like that, you can add additional avoidance models here and give them a value to avoid by. Awesome. Any other questions so far? Going once? Demio? No? Going twice? All right, let's move on. So, next page. Hole making. Okay, so hole making. This is the last one I'm going to do like really in depth today because there's just too much to cover. But I think that this is something that applies to a lot of people. So does Mill, right? When I'm looking at the people who own Mastercam and how many licenses have been sold of each type, Mill is huge and everyone makes holes, right? So that's kind of what I'm focusing on. So there's been a lot of updates to hole making in the last couple of years especially. They've really been working hard on hole making over the last 2-3 years. And I want to show you some of the updates here. And I'm going to be using a part that you could make in a 3-axis or a 5-axis machine. And we're going to talk about the selection for drilling, major differences there. We're going to talk about adding chamfers really effectively and easily. We'll talk a little bit about multi-axis and the way that that works differently between the versions. There's also advanced drill, hole segments, and process hole. We don't have time to go over these today, but I will say that advanced drill, that has a place on this part, and we'll see it later, where we've got like an 1/8 inch hole, but it has to go more than 2 inches deep. It's pretty far for a drill that size. And if you wanted a cycle where you had you take your short drill, and you maybe cut that the first 3XD, 5XD, then you want to follow that with a longer drill. You start at a low RPM, guide the drill into the hole before you turn it up, because otherwise you get drill whip, right? Which I am still looking for a really good video on that. If anyone has a great video on drill whip, please send it to me. I want to see it. Huh? Do you have a high-speed camera? That'd be sweet. But you get drill whip if you turn your drill up too fast without any support when it's a really long drill. So the advanced drill, what it can do is it creates a special output where your tool can actually slow down, go into a hole, and then speed up, and then cut, and then come back out, and kind of do whatever you want too. It's not just for that. What if you wanted to cut through a void, right? If I'm working on a casting, and on that casting there's walls. It kind of looks like this, and there's a hole that I got to go through here, right? Imagine these are bigger. If I'm drilling through and I'm just going at my normal feed rate here, we could be wasting time. Advanced drill can allow us to speed up the feed rate in this area so that we just punch through quickly and get to the metal, right? So advanced drill, essentially what it does is it replaces the vast majority of the needs for custom drill cycles built into a post. You can just build your cycle yourself. It's not really a cycle anymore. It just becomes G-code. It's all G1s, you know, spindle up, spindle down, coolants, options, all that kind of stuff. So it's not a G81 or anything, but it's fully customizable. You can do anything you want, and you can save those parameters. So if you have a set of parameters that work well for multiple parts, you can just import that into your other parts and then adjust as necessary. Hole segments is born from Mastercam's much more robust hole definitions within solids. We can actually read the different sections of the hole depending on their diameters and lengths and adjust for those accordingly, which is really neat. We don't have time for it. And then process hole is brand new for 2024. It essentially allows you to pick holes, and as long as there has been a process that's predefined for that hole, it can program it for you automatically. Anything that's hole making. Spot drilling, counterboring, threading, whatever you want, it's all supported. So it's really cool. We actually have a video that we put up somewhat recently on that, so check that out on our YouTube channel, or you can go to mcamnw.com/videos. We've got some stuff up on that. So let's go ahead and get back to my computer, and we're going to take a look at this this other program here. Okay, so relatively simple part. Just got a bunch of holes in it. There's 3 different size holes here. These are like 0.93.5. These are 1/8, and these are like 159 something. It's a number drill. I don't remember what it is. I've never actually been good at like knowing what the fractions and decimals are. I'm not actually good at that. So 2017, if I wanted to drill holes, like let's say that I wanted to drill these 4 sets of holes, how would I do that? Well, if you've been using older versions, you might already spot a problem, which is I don't have any wireframe on screen, right? I just have the solid. The problem with that is if I go to drill and I'm trying to select things here, I can use my automatic selector, I can use entity selection, and I can't like window select. I can't pick a bunch of these at once. I'd have to go one at a time and pick every one of these holes, and then I screw up, and then I got to clear it, and then I got to do it again, and oh, the time is bad. So how do you get around that? You use wireframe, right? But that means that I have to now go through the process of figuring out a level to put this on. So I'll put it on level 2, call it wireframe, go to my wireframe, do curve all edges, select my part, and then green check. Now I have wireframe, which is also all a weird color. Let's make that more visible. Now I can go to my drill, and I can use mask on arc. And I make my selection, go back to a top view, Windows select. There we go. Hopefully it only selected the thing I wanted it to select. And there's our whole selection. Okay, so you can do it. Yes, I'm not saying you can't. I'm saying it's a lot of work, right? And maybe it doesn't feel like a lot of work when you're used to it, but then when you get into a newer version, you realize that it's a lot of work. So if I'm in 2024 and if I run the same program, again, this is the exact same program. I'm loading the same one. It's got the little yellow bar. if I want to drill, I select my drill toolpath, I zoom in here, and I'm going to do a control click. So I hold control, and then I click this solid wall. And that picks every one of those holes for me, just like that. So I mean,
picking everything at the same diameter.
Everything at the same diameter. Well, technically the same radius. So that's the one kind of trick with this, because you can sometimes have a split hole. It uses radius instead. That does mean that if you have a hole that happens to have the same radius as like a little fillet in a corner somewhere, that can be selected. So you do have to kind of watch for that. But for the most part, it's really a time saver. Control click. So I held control on my keyboard and then I clicked. In fact, if we look right up here, those are selection cues. So these actually help you figure out what you can do in a given situation. I know that once you've been programming for a while, you kind of start to ignore these. You're like, yeah, it's just the thing that's in my way. I'm just trying to get my job done. No, they're there to help you. This tells you all the different ways you have. So you have control click to pick everything of the same radius. You have control shift click to pick everything with the same radius and is in the same vector. Really important for multi-axis work. You can double click to select whole features. So rather than, here I just selected a face, right? But if I wanted the whole definition itself, everything from the counterbore to the chamfer to the through to the whatever, it's a double click. Control double click to get all of the solid holes with the same type, right? So you have lots of different options for that type of selection. Yes? Has the feature been around for a couple of years? Yes, it has. When was it added? I don't remember, but it was after 2017, that's for sure. Yeah, I don't remember exactly. Was it around? I'm trying to remember. The earliest I really have like experience with is 2019. Before that, I had used Mastercam, but I wouldn't say I was a programmer. It was more of I was noodling around and getting not a lot of instruction on how to do it. Yeah, 2019, did they have this? Or was it 2020? 20, yeah, 20 or 21, somewhere in there. So yeah, and again, not everything I'm showing you here is new to 2024. It's just what are big things that have happened since 2017. So the other thing that's really cool about this, let's say I'm gonna grab my tool. So this is the 330 seconds. We're gonna do a regular drill. My linking parameters, check this out. We have this really awesome thing where it actually shows you, and depending on, this is a lot of holes, so it's a lot to look at, but these little boxes here, they actually show you the heights for each one of those holes incremental from the hole itself, which is really useful. And the behavior of those change depending on whether you're incremental or absolute as well. But let's say that I want my retract to be, let's just make this 50 instead. I'll turn on clearance at 2 inches at the start and end. Okay. And I'm going to turn on my tip comp. And in this case, let's consider like these holes over here. These are actually through holes, whereas all of these are blind. So if I want to hit the blind hole ones, I would want my tip comp at 0 so that it just gets that diameter all the way down. If I want to get through the part, I would need to add a little to my tip comp. So in this case, if you did have all of them together, you have to violate one way or the other, right? Either you go a little deep to get through, definitely through on this, and you make these a little deep, or you make these exact, and this one, it's like theoretically through, but you're right at 0. It's a little sketchy, right? It's up to you what you want to do. You just break it into 2 operations too. It wouldn't be too hard. But, so that gets us this, and this is unsorted too. Like we can go back in here and resort this. Let's say I use point to point starting here. Regenerate. It also generates really fast compared to 2017 for that many holes. But here's the part that's really cool. So the linking parameters for hole making have been updated. If I look at this from a front view and use Alt-S to clear that out, well, actually maybe a left view is better. If we look closely, we'll see that all of those were drilled to the perfect depth on all of these holes. But what's really interesting is that the holes are actually different depths relative to the top of the surface. The ones down here are through. These are like 1/2 inch. The ones behind that are 625 deep, and then these are like 750 deep, and it accounts for all of that. So even if your holes are different depths, it doesn't matter. It can account for all of those things when you're using the incremental tool, options. And that's all based on this checkbox for calculate incremental values from holes or lines. 2017 cannot do that. So even if you got your selection all figured, you'd still have to have 4 toolpaths to do what I just did in one with 2024. The other thing I wanted to mention was the chamfers. So we've got some chamfers on all the holes in here, right? We've got some on these holes and then some on these, and they're different size holes, so the chamfers are also different sizes. So this would be minimum 3 operations to do, right? Small, medium, and then the large ones on the outside. You could actually do this with 1 toolpath using the chamfer mill or the chamfer drill toolpath, which is right here. Now, in practice, in real life, I would use 2 because I would set up these and this one as a 3-axis toolpath, and then I would set this up as a 5-axis toolpath separately. It's a little cleaner in terms of when it actually runs on the machine and sorting and all that stuff. It's a little cleaner. That's what I would actually do, but you could do it all at once. But what's neat about the chamfer drill, if we come in here and we're going to do the same thing, control click to get all those, and the same thing over here, control click here. We've got 2 different size chamfers, but Mastercam will actually compensate for that based on the geometry itself. All I do is pick my chamfer mill, and then here, similar to model chamfer, if my chamfers are already modeled in, I just leave this at 0. That's all I got to do. It will figure out everything else by itself. Again, we're gonna reduce this retract to like 50 clearance, start and end. Okay. This also helps with like the clearance thing to break it into 2. And oh, I messed up my plane. Yeah, you can tell. You see the lines going sideways like that? That's me messing up my plane. Happens to all of us. Let's try that again. I also love that little generate toolpath checkbox. It's awesome. Again, unsorted, but it does compensate for the different depths as necessary. If I get one up top here. Cancel. Yeah, that was my fault, making a mistake there. We can see here, if we zoom in, you see how the see the little striations here. That means that it's perfectly matched up. And then if you move forward up to the holes up here, it's doing exactly the same thing, even though they're different sizes, in different heights, and different everything. As long as the actual angle of the chamfer matches, you'll be fine.
Are you using a multi-flute countersink, or are you using a chamfer mill?
I'm actually using a chamfer mill for that because these all happen to be, 4590 chamfers, so it makes more sense to do it with that tool.
Right.
It makes a great chamfering tool. I mean, for countersinking your hole, it works really well because you've got the extra flutes you can really move. You might consider using a little bit of dwell just to make sure it's nice and clean, which is an option in the cut parameters.
How do you know with your machine, your post, is that 1 second, or is that like you may have to put 1,000 in there to get 1 second?
Oh, for the dwell.
Yes.
Oh,
so it's going to output a G04X, or is it going to put output a G0 with a P?
Yeah. So the question was, for those of you who couldn't hear it, how do you know what to set in your dwell? Because each post might handle it differently. Yeah. I don't know. I honestly don't know the answer to that. I was just thinking about it the other day, that There's some commands that seem to behave differently depending on your post, and I really just don't know without testing. I'm also not a G-code expert by any means. I like this side of the thing, but as soon as it's out of here, it's not as much my ballpark. That's where I call Jeff.
Postability has a translator in the post for it.
Postability has a translator in the post for it.
Yes, if you go between like a Haas and a Siemens control, it'll auto change. If you put 1 second in and it needs it in 1000.
Got it.
Do the translation.
Okay, so there's translations built into the post, and it might depend on who you get the post from too. Because we get a lot of our posts are from Postability. Some of them are from Mastercam, and some of them are from in-house solutions occasionally. I think those are the 3 major ones we have. But yeah, Postability has a switch in there. So if you want more information on that, please feel free to reach out to us, and we'll take care of whatever you need with your post. But yeah, I don't have a good blanket answer on that, unfortunately. Where are we at? Oh, wow, we are running out of time. I didn't even have time to finish this. I have to get on and show you guys some other stuff. So let's move back to the slides for a second. So lathe and mill turn, really awesome updates in here. Is anyone programming lathe with an older version? Anyone here? You are? Okay. Well, have you ever seen the dot machine environments? These are post bundles, basically, where you get post and simulation all wrapped up into one. And they allow you to do much more than traditional lathes. This actually has been supported since 2017, but the number of machines that have been supported has grown drastically. We have a lot more machine support now. Additionally, you can now run Swiss machines with lathe definitions as opposed to needing the special like Swiss module thing, whatever that was complicated and a lot of people didn't like. You can do solid chaining on lathe. We have angled and aggregate locators. So if you're running a turret style machine and you have a tool that you kick off at an angle with one of those special locators, we support that as well. B-axis contour. So if you need to move your B-axis while you're turning, if you have a head machine like that, you have that support. Steady rests, whether they are integrated into the machine or they're bolts onto the turret, those are all supported as well. Just a lot of different options, you know. I really love this tool as well. This is from Sandvik. They call it a mini turret. They have little heads that bolts onto it, and then you can rotate the spindle axis to change tools. Really neat. So if you go back to my computer for a second, I'm not going to actually pull up the program. What I'm doing is running this exe file. Whenever you create simulations in Mastercam, you have an option to create what's called a presentation. It's an exe file that essentially runs that simulation, and it's all compacted into a single file that you can transfer between computers. The best part about it is that if I didn't have Mastercam installed, I could still run this. This is really, really nice. If you wanted to take a job and send it out to the shop, you can give them your setup sheets and the program and these files. They can run it on some shop computer with no Mastercam, and they can actually watch the simulation before they run it so that they know what to expect as operators. Really neat. So here's that dot machine environment with the skins on it. Those are for collision checking. That's actually fully collision checked. So if you have drills that stick out, that will catch it. You can turn it off in the visibility, still checking in the background. Let's zoom in a little here. I'm going to run this in length mode. I'll try to slow this down a bit so we can see that style of tool. So this is something that we definitely didn't have in 2017. That came out, I think last year, maybe the year before, hard to remember. Super useful though. And we're seeing more and more tools like that, especially in the high end. So then we're going to get out of the way. We're going to pull our part forward and engage that steady rest so that we can do some more work on it. And then we've got our B-axis angle in here. So it's going to come in and cut this way instead. And then I think it's going to switch to a different tool. Because I think this is a D and I'm going to switch to a V. So it spins that around. and then we'll B-axis contour to finish it off. So we'll actually see the whole thing spin. So none of that was possible in 2017 at all. So that's pretty cool. If you've got a turning center that has a B-axis head or has a Y-axis in the turret, these stop machine environments are amazing. They do so much. Can we go back to the slides too? So on the next slide, we have multi-axis as well. There's a bunch of new updates to multi-axis. The deburr toolpath, that was introduced in 2019, and we've been developing it more. So we've got a lot more tool support now. We now support ball mills, lollipop tools, chamfer mills, dovetail mills, flat end mills, bowl end mills, and taper end mills. Whew. I'm impressed I remembered all those. So you can use all those styles of tools to deburr your part in multi-axis, which is fantastic. And what's really cool is that depending on which tools you're using, you can actually lock it to 3-axis. So even if you don't have a multi-axis machine, if you get a multi-axis license, you can still use those toolpaths, which means you can deburr your parts more effectively, which is really nice. Common direction, that's a feature that allows you to actually change the way that your rotaries work. So rather than having simultaneous motion in your rotaries, it can move to an angle and lock and take a pass, then move to another angle and lock and take a pass. Really useful if you're cutting material that's very light and you're moving too quick for your rotaries to keep up. Or if you're working on really, really tough material that might actually, that your rotaries don't have the power to hold back against. I've seen that. Not fun. I've run into both. The unified toolpath is like the all-encompassing multi-axis toolpath now for finishing in general. It does 80% of the multi-axis finishing you're going to need on its own. It's incredible. If you're used to using morph and parallel and stuff like that, it's all built into unified now. So one interface makes it much easier to use, makes it easier to change your mind. If you decide, you set up parallel, but you wanted morph, you don't have to make a new toolpath anymore. You just change the strategy. It's easy. So, and there's even more, but we're really running out of time, and I just wish I had more time. But lots of amazing support. If we go back to my screen now, we can see this is a simulation. Ooh, it's moving a little quick. We can see a simulation of some of these updates though. So this looks like an OptiRough or something like that, but this is actually 3+2 automatic, where it will look at your part and figure out different angles to come at it from to do the roughing for you. So you don't have to set up your planes. You don't have to set up multiple operations. It's all in one. Super cool. There's some caveats to working with it, and it takes some time to learn, but once you get it down, it's really useful, especially if you're either doing prototyping work and you just kind of need to get things done quickly, or if you're working in a scenario where you're working from a huge piece of material that you have to whittle down, you could just wrap a quick bounding box on it that's just kind of close to the shape and at least get the machine rolling while you continue programming. Really useful. So you see it kicked over. That's all one operation. I think we're getting close here. I'm going to switch or skip forward here. And so here, this is circle segment tools being used to cut down the side of this. So that tool has a profile to it that's not regular. And what's really neat is it means you can cut through your material much more quickly. It's taking 100,000 step downs and getting a finish that's better than taking a 1/2-inch ball mill and doing 3 times as many passes. Really useful. In this toolpath, this is using the common direction. So it's actually breaking up that rotary movement as much as possible. There's some cases where it can't do it, but whenever it can, it's going to lock that rotary down, which is a really neat option. And then, of course, we have the deburr toolpath. So here, let's get a better angle on this. Whoa. I missed my 3D controller. There we go. You get used to it. It's hard to not have one. So here, we're using a chamfer mill to do just general purpose deburring on kind of any edge we want. And it's whipping around a little bit here. But using a common tool that most people have laying around rather than something fancy like some lollipop tool that you're going to use twice, right? It's nice. After going through these last couple of things here, let's go back to the slide deck. That really, on the next slide here, it really just boils down to simulation is going to be a big deal. Having a good, reliable simulator is fantastic. Doesn't matter where you are, right? If you're at a nice high-end shop, you got really expensive machines. If you are not, you need to make sure that you're running it correctly. If you're at a school, oh, you really want simulation, right? You got students who don't know, like they don't have enough experience. So always simulations. We just generally have more support for simulation tools in more modern versions of Mastercam, including our postability bundles, which is a post and simulator bundle. They come together, they're packaged. Postability bundles are really cool because they actually run part of the post processor, get some of those values and use it to show the moves in the machine. So it's not just NCI simulation, it's a step above that. It's not true G-code, as a lot of people like to put it, but it's really, really darn close, and it works the vast majority of the time. And then we also have Simco simulation. If you wanted to actually read G-code and see it in a machine, we have that as well. It's another option. And depending on the situation, depending on what kind of machines you have, it could actually be a better deal in terms of money. So it's another thing to consider. All right, so that's it. I am like, what, 2 minutes shy of hitting the full hour. Oh, that was close. So if you guys have any questions, I'm happy to answer those. If there's anything you want me to go back and talk about again, if I skipped over anything you felt was important, general questions, personal questions.
Home learning edition, you still have to have a robust graphics card. You can't run it on a motherboard graphics, right?
The question was, with the home learning edition, do you still have to have a pretty robust computer meeting the specifications for Mastercam? Yes, that is still true. So the home learning edition, just to be clear on exactly what it is Mastercam. It's not a version of Mastercam. It's actually just Mastercam, and you have a different license that tells Mastercam that you're not allowed to post or use C hooks. That's kind of it. And you can't use binned posts. Well, no, I guess you probably could up to a point, like for the definitions.
Yeah, you can use it for the definition.
So yeah, it's mostly just a limit on posting. That's the majority of what it is. But it's still Mastercam, so it requires all the same stuff.
And your mesh imports, that's still an STL. You can't convert it to anything else.
Mesh imports, can they be converted? Yes, so there are other formats that Mastercam has supported for mesh. So, okay, so if we hit this drop down, oh wow, yeah, it's now so long that doesn't fit. That's cool. Let's see. I'm trying to remember what all of them are too. So one moment as I kind of think about it. So there's STL, that's your standard, right? And then we also have, 3MF, 3D manufacturing format file. That is a type of mesh. OBJ, I think that's a type of mesh.
Yep. So what I meant, when you bring it in though, it's still an STL file in Mastercam. You use that STL file as your stock. The Mastercam cannot convert a mesh into a solid.
Mastercam cannot convert a mesh into a solid. That is correct. We actually do offer a different product that does that. Space Claim ANSYS.
You can do it in Verisurf.
And you can do it in Verisurf. So there's a couple of ways to go about if you do need to convert that into a solid for some reason. But a lot of times you could make a STL work for the application. If you're running into something specific, let us know.
Yep.
Anything else? Anything in the chat? I know I'm starting to get hungry.
Nope.
Nothing in the chat. Any other questions here?
Has there been any work on the hybrid toolpath at all? It seems like it's kind of gone downhill over the last few years as far as like its ability to recognize like floors. Like in a lot of cases when we try to run to detect flats on like mold surfaces and stuff like that, where it's conflicting with drafting rooms, it really has a problem with it and starts to error out more often.
Okay.
Any kind of like direction with that?
Okay, so the question was, has there been any improvements or work done towards the hybrid toolpath, noticing some less than favorable results in some situations, especially with the drafted walls, it sounds like. To my knowledge, like I don't really know. There's probably been an update for hybrid kind of recently. I just don't really remember it. But if you're running into a specific issue, we're always available for you. You can send us an email at support@mcamnw.com and let us know what's going on. You can send us what's called a zip to go, where we get your part file and your machine definition so that we can mirror exactly what you're doing and see if we can get a different result. Cool. All right, any other questions? Going once, going twice? Who's hungry for lunch? I am. Excellent. All right, I think we'll wrap it up then. So thanks for joining us, everyone. We really appreciate it. And we appreciate you at home as well, or at work, or wherever you happen to be. Maybe the Bahamas, that'd be nice. So our next webinar is going to be next month, October 17th. 17th? I think it's the 17th. And we're going to send out emails, of course. But we're actually doing our official 2024 rollout next month. We're actually going to be doing it live in Hawaii. So if you guys want to buy a plane ticket, you're welcome to register. Otherwise, we'll have it. Otherwise, we will be streaming it live on Demio as well, and we'll have a recording available at mcamnw.com/videos. Aside from that, I think we're good. So awesome. All right. Well, thanks for joining, everyone. Thank you guys as well. We'll have a good day.